Hey guys, so next lesson are benzene rings. So we talked about our aliphatics, we looked at our alicyclics, and now we're looking at our aromatics, which is benzene. So a little story behind benzene. So scientists knew that the structure or the chemical formula for benzene was C6H6. So basically what that means is that in order to get that, you would think it would have the same formula as an alkene or a regular there would have to be some units of unsaturation in it for making double bonds or triple bonds. But what they found out through many tests is that it didn't actually have a double bond. So there's different tests that you can do to determine if there's a double bond, and we'll talk about those later. And basically there was no presence of a double bond. So they were very, very, very confused on how it actually had that structure, C6H6. So after trying to figure it out, there was a scientist that was able to solve the problem. So I just have a quick video for you guys to show on that. And I was called Kukuli. Apparently, I think I was saying his name wrong. So we'll quickly watch this video, and then we'll talk about how the structure of benzene it was discovered.
He had a dream. He saw chains of carbon atoms writhing like snakes before his eyes. He had been thinking about the structure of the benzene molecule. He knew it had 6 carbon atoms, but its structure was a mystery. Benzene couldn't be a simple chain, so what was it? Suddenly, one of the chains moved forward. It seemed to be a snake biting its own tail. This was the answer to the riddle. Benzene was a ring of carbon atoms surrounded by hydrogen. This ring is a key feature of the architecture of many carbon molecules. In fact, all sorts of carbon rings are found throughout our bodies and in our fuels. Kekula awoke knowing that he had changed chemistry.
Okay, so yeah, they found it was a ring. And the reason why they were able to figure out the units of unsaturation was essentially they figured out that there was actually what's called half bonds in order to make up for those extra hydrogens that are missing. So they knew the formula was C6H6. And this controversy lasted for 40 years until, oh gosh, Kakua, I thought it was Kukule, the guy in the video, join the two ends of the carbons to a cyclic structure with an alternating single and double bonds. So we talk about a resonant form, which basically means it interchanges back and forth between this structure and this structure. But in reality, what it really is that we have these half bonds that are kind of scattered throughout it. So we often just show it as a circle. But really what it is we have our single bond and then a half bond in each. So they kind of share the bond. So essentially, because the resonant forms are going, back and forth. So we have 1, 2, and then we have our hydrogen bond, and then 3.5, 4. So that's how we have our 4 bonds on each carbon. So I'll just fill that in. All right. Yeah, so that's basically our benzene from there. And sorry, I just need to open up my notes for it. Forgot to do that on my sheet, just so I have the filled in so that I know what version you guys are looking at. Okay, cool. All right, awesome. So what it does is it basically acts like a hybrid. So that extra half bond. But what was interesting is it acted as a saturated hydrocarbon. So as I told you guys, they didn't actually know the whole story behind it because when they did the tests on it, there was no unsaturation, there was no presence of unsaturation, which would be a double or a triple bond. So we talked about this a little bit on lesson 3. It acts as a phenol when it's a branch. So hence, DDT, the dichlorodiphenyl, the substance that we use as an insecticide, we saw that word phenol, or the polyphenol chlorides. Again, that's when benzene is acting as a chain, so just like a methyl group. So when we take a look here, okay, this would be called methyl benzene. All right. And then this would be 1, 2, 3 trimethyl benzene. Okay. And then our last one, we have our structures, and again, we're going to prioritize alphabetically. So we're going to give this a 1-ethyl because E comes before I, so this would become 3-iobenzene. Okay, awesome. So the old way of naming this is using the ortho meta para, and I'm just going to give you guys a quick little video to show you guys a nice little song to remember how to name these guys.
Ortho, substitute 1 and 2, I say meta. Substitute 1 and 3, I say para. Substitute 1 and 4, OMP. Now sing with me. Ortho, substitute 1 and 2, I say meta. Substitute 1 and 3, I say para. Substitute 1 and 4, OMP. Now sing with me. It's fun to sing about my benzene ring. It's fun to sing about my benzene ring. Substitute methylene and you have toluene and H2 for aniline. It's fun to sing about my benzene ring. It's fun to sing about my benzene ring. Add OH propanol, phenol's missing an H, and O2 makes nitrobenzene. Benzene is unusually stable, it's cyclic, planar and hexagonal, a hybrid with 2 resonance structures. Of course, it's conjugated. Huckel gave us 4 plus.
All right, so we'll stop there. That's good enough for that. Now you won't be able to get that out of your heads for that. So yes, ortho, meta, para is the next way to name them. So it only is true when you have 2 branches, and again, this is just a different way of naming things. So when we take our resonance form, okay, I'll just make it with a circle so that it's easier for that. So we have a 1 and a 2 substituted. Okay, so for example, if it's methyl on both, you would just call this one O for ortho, dimethyl benzene, and of course the previous way would just be 1,2 dimethyl benzene. Okay, for a meta, substitute 1 and 3. Okay, so it doesn't always have to be the same. In these examples, I'm just using methyl to make it easier. So this would be M for meta, dimethyl benzene. And then substitute 1 and 4 is going to be, so we have a CH3 here, and let's go down here, and let's actually change it up a little bit. Let's put C2H5. So this one would be called P for para. Ethyl comes first alphabetically, so P-ethyl methyl benzene. And of course, the old way would just be 1,4, or 1 1-ethyl 4-methylbenzene would be the old way to name that. Okay, all right. So, very, very short lesson. And there you go. Our nice little Lord of the Rings joke. Again, it is missing the circle or the alternating double bonds in there, but again, I think you understand it. Nice little joke. Mercedes Benzene. Haha, get it? Benzene. Nice. Yes, the dash thing means half of a bond. So something new and very, very, very unique to benzene. All right. So this is our lesson for benzene.